check. That's why, because I'm scared if it doesn't work properly. I'll just double check and then start it.
Okay.
Right now, I'm just checking on YouTube if we're live or not. Awesome. I can hear an echo, which means we're live. Sorry, I had my monitor glitched out. Just 1 second.
Okay.
Awesome. My monitor got disconnected. I'm sorry about that. Hey, everybody. Welcome back to Chai Time Kaggle Talks. I'm super excited and really honored to be talking to Qishen Ha today. I was told that's the correct pronunciation. Qishen, thanks so much for joining me today.
Hi, everyone.
So I want to point out to the world that there are about 176,000 Kagglers who've dared to sign up for competition. Chishan is sixth, number six in the top 10 of the worldwide ranking. So it's an absolute honor to host him. Today I'm having chai at the actual chai time because Chishan is in Japan. So luckily it's evening for me. And we'll be learning about his journey and how did he win how did his team finish number one on the TensorFlow GBR competition? So I'll quickly introduce the session and the agenda and then move on to talking about Chishan's background. So this is part of Chai Time Data Science 2, where I try to interview my heroes and also understand their solutions. So the agenda for today is to understand how did Chishan become number six worldwide? How did he get to the top of world rankings? Then we'll try to understand the TensorFlow competition and then his solution. So I want to start by asking you, I believe you have a background in economics. How did you get interested in modeling and machine learning?
Yeah, actually, when I college, like the first or second year, I found that I actually not that interested in economic. Okay, so at that time, I was just like learning, studying Japanese and some programming skill by myself, and I found that I'm really interested in computer science. So, but it's really hard to change my major in in my college. So I didn't choose to change my major in my college. But instead, when I graduated from university, I come to Japan and try to enter um, postgraduate school of information technology. So yes, actually, I learned many things, uh, laboratory that are working on computer science, specifically deep learning. But kind of like incidents because I don't know much about high tech technology things in computer science. Just like writing code by myself, but don't know much about high tech things at that
Mm,
time. So it was kind of incidents that I can join a laboratory that are working on deep learning, and finally I find out that I'm also interested in deep learning. That was a kind of good result for me. So yes, I'm really thankful to my my boss. Yes.
how did you practice programming when you started? Because you come from a different background, how did you
Yes. Yes.
practice Python and learn these skills?
Yes. At first, I buy some book like that are some basic knowledge like C++ one, Java one, or at that time Python is not that popular yet. So yes, so I learned C++ and like objects, uh, Java,
Mhm.
and then something like database and network and uh, web and like web applications. I read many books and look at many videos to learn that, but without anyone teaching me. Yeah.
Okay. How did you discover Kaggle? Your first competition, I went through your competition history. I think it was the Red Hat or the Salt identification one. How did you find Kaggle and how did you get addicted to it?
Yes, actually, if you don't mention that two competition, I even don't remember that I have ever attempted that two competition, because actually I just um, like to finding some public data sets. You know that at that time, before 2000 and maybe 16 or 17, there are not that much public available data set yet, specifically in computer vision. You know that labeling large size, large scale image data sets is very expensive. So we usually use like Coco or ImageNet to do our experiment to figure out whether our trick, our new idea works or not. But actually, sometimes if we only optimize one or two data sets, we might over optimized. It's kind of different from overfit. I call it over optimized. It says maybe this trick is work at ImageNet or Coco, but somehow not working on other datasets. So to prevent it, I would like to find some new image public available image dataset to figure out whether our new ideas or tricks works or not. So maybe at that time I find Kaggle that there are many public datasets at Kaggle that I can freely access. So I'm quite happy at that time. But actually, I don't attempt competition very seriously, just like downloading their dataset and try some new things. Yeah, at that time.
That sounds like my approach right now. So I just download 4 kernels and don't do anything. That's all I do.
Yeah, yeah. Actually, that is the choose.
There's someone who saying they're joining from China. Thank you for joining. Uh, I wanted to ask you, how did you then, once you had found Kaggle and you got interested in computer vision,
Yeah.
how did you improve on Kaggle? Because you've taken competition very seriously. That's what I believe. It takes a lot of efforts and brain also to get to the top. How did
Yes.
you improve on Kaggle?
Okay. So, like the first competition, very seriously attempt was a natural language processing competition, which is called Jigsaw, the second Jigsaw competition.
Mhm.
And at that time, maybe a little newer, a little bit. Uh, I
Yeah.
think it's a solo gold.
Oh, okay.
Yeah. Yes. Yes. The eight. Yes. Jigsaw unintended bias in toxicity classification one. So actually, at that time, because when I was in laboratory, I was working on computer vision. So actually, many people are working on natural language processing as well. But actually, during the 2 year I was at laboratory, I don't know anything about NLP. So, but I personally was very interested in NLP. So I was a very long time. For a very long time, I looking forward to learn and to master NLP skills. Like at that time, it's still like LSTM or GRU or something like that.
No
But
transformers, no transformers or no attention back then.
yeah, so it's still a transformer was not born yet. So yeah. So I was very interested in NLP. So at that time, I find that there is a new Kaggle competition coming up that is natural language processing NLP. So actually, I was just like wanting to learn how to do NLP to attempt that competition, but not to win or not to fight with any other guys, just to learn. And at that time, I read very many discussions, many public notebook, and figuring out how people preprocessing text data, how to modeling that, how to do tokenizer, how to like build LSTM models and even BERT models. So at that time, it was just like the first year of uh, BERT
Hmm.
was born, if I don't remember it wrong. So it was a very good chance for me to learn many new NLP technique, and like how to say, it was another incident that I finally finished in the solo solo code. So actually, that encouraged me very much in competing in Kaggle. Yes. So like this is my first time very seriously to attempt a competition, and I finished in a solo goal, which is the biggest difficulty for being a grandmaster. That was accomplished by my first competition. So
May I interrupt you for 1 second?
okay, no problem.
I just want to tell the audience, this is like Chishan said, this is the most difficult possible thing to do on Kaggle. One of the most difficult things to finish in the gold medal zone by yourself. So as you can see, there are many people who have formed teams, but Chishan finished by himself in the eighth rank, and this on Kaggle is one of the most prestigious and difficult things to do. So just wanted to emphasize on that. It's really hard to do.
Yes. To be a grandmaster, you have to have a solo gold. So like when you have a solo gold, then you can have a you can just team up with other guys and attempt other competition to get gold medal, and then you become grandmaster. But the most difficult thing is to have a solo gold. Yes. So I mean, um, it's just an incident that I can get a solo goal. I can get a solo goal for my first competition. So I mean that encouraged me very much. So I decide to my continue to join other competitions like maybe can you show the my competition
Yep.
list? I actually that was 2 years ago, so I don't quite remember which competition I have
This
joined.
one.
That's my first team goal, but not that one. So actually, the second competition where I joined Aptos. Yes, that
You
is my.
have won so many medals, you are also forgetting where you had solo gold.
Sorry for that. Yeah, the second competition I joined was Aptos, and at that time I got my second solo gold. So that was another very encouraging things for me. Yeah. So Actually, I have 3 solo goals in total, and after that, many invitation was sent to my emails, and like many people want me to be part of them and competing with them, and so like that attempting joining a competition solely was like you feel very lonely, and you have to work very hard. You have to deal with everything you face. So it was quite hard time for me to do solo. So it was time to team up. So I was just thought about that and team up. After that, I haven't done any solo competition
Okay.
from yes from that time. Yeah.
There's
So yeah, please.
please continue. Sorry.
Yeah. So after teaming up with many like Bo and Gary, maybe you know them,
Yeah.
and I find that to team up with other Grandmaster, and I find that it's really, really very easy to get to gold zone, even the green zone, you know that. So yeah, after that, I just give up solo in competition.
There's a question, and they are asking about your self learning. So when
Yeah.
you started solo, how did you learn by yourself? Kaggle is so challenging, so
Yeah.
overwhelming. There's so much information. How did
Yes.
you get gold by yourself just starting out?
Yes, I think because I don't know anything about NLP before I joined Jigsaw competition. So maybe I can give you guys some advice about that, because yeah, you can imagine that I actually know nothing about before I joining Jigsaw competition. So I think the first step is to read public notebook from the competition. You can see that there is a like sort by public score button in the like right top side, and you can just see which notebook has best score at public leaderboard. And yes, best score, yes, like that you can see which notebook has best score at the public leaderboard, and then you can read it to um, learn how they deal with the datasets, how they build model, how they set hyperparameters. And then once you read many of those things, you have some ideas, like maybe reduce learning rates is better or not. You can have try by yourself, and you have many ideas by yourself. You try them, try and error, and do many experiments. And just like if you get stuck and you go back to discussion or other notebook and find out other and learn other new things, and then you get back to your experiments and just do it again and again, and then you finally find that you have uh, learned many things. So you actually don't need to care about where is your ranking finally uh, landed. Actually, I didn't care about that at all, because finally I didn't just like I believe I was 32 place or somewhat at public leaderboards, which is civil zones, but I finally shake up to gold zone. So you don't need to care about your ranking in public leaderboard when you want to learn something, actually. Yeah. The key point is to learn.
Thanks for answering that. For some reason, this public leaderboard doesn't show anymore. Maybe Kaggle removes it after it's been a few years.
Okay. I didn't know that.
You're also very active in discussions. I believe you're really close to becoming a grandmaster there. how do you suggest beginners engage in discussions? How can they contribute there? Or some people ask very easy questions that they can just look up. What questions should they ask, and how can they learn best from there?
Yes, yes. Actually, like I don't like to ask question. Actually, that's because I learn many things by myself without teacher, including computer scientists and Japanese. I don't have a Japanese teacher as well, and
Okay.
but I can, yes. So actually, I don't like to ask question like although like when I read notebook or discussion at the cargo competition, I found that maybe um, the um, the people, the person of that notebook of the is not making his idea very clearly by I think we all have the experience that you find that there is something maybe hidden by the author of the notebook or discussion. So
Some secret that is hidden in there, and you have to understand yourself.
yes, so actually maybe although you ask him, he might not answer you. For most of the time. Actually, specifically before the end of the competition, maybe after the end of the competition, they would like to answer you, but probably not before the end of the competition. So when you find that you have some question about their idea, you can try the idea by yourself, or simply just choose not to trust them. It's very, very simple. Yes, actually, when I have attempt like 20 or 30 competition for these 2 years. I have read many public notebook, many public discussion. So for my experience, there are around like 60% of the discussion, like he says this trick is not working or that trick is working, and after I tried it by myself, 60% of them is actually the opposite of what the result is the opposite of what they said. So you have to try it by yourself to find out if that trick is really working or not, but not just listen to them. That is quite important when you learning things. Just not trust them directly. Try by yourself.
That is such a beautiful advice. That don't like, one of my mistakes, or maybe because I do the podcast, I use
Yes.
an excuse is I just read and I don't implement things. I think many people do that. That's the
Yeah.
difference between a competition expert and grandmaster implements everything and tries it by themselves. Sorry,
Yes.
did I
Maybe they are
freeze?
just. Yes. Maybe there is some
Sorry,
network.
that, sorry about that. I'll repeat. I was saying that's the difference between a competition expert and a top ranked grandmaster, is that a grandmaster tries everything and a noob just reads and doesn't do anything. Um, so there's another question. How much time were you spending every day during your first solo gold medals?
Okay. So actually, for the past 2 years, I spent like 90% of my personal time. I have a full time job, but besides the full time job of my time, I spend 90% of it to do cargo competition. It's quite a lot. Yeah, I actually in the past 2 years, my memory is full of cargoes. Yes, it spent quite a lot of time to to get a gold, specifically solo gold. Yes.
Do you ever feel burned out from this? Like, of course, everyone loves Kaggle, loves experimenting, but how do you like balance it, or how do you take a break? How do you ever take a break? Or
Yes, of course. I like video games or animations. That's the main reason why I come to Japan. So yes, but actually most of my hobbies are indoor. I just like sitting in front of my computer and I can have fun.
okay.
It's nothing from haggling, just sitting in front of my computer and just looking at the screen and do something.
That's awesome. So what's the most challenging thing for you today on Kaggle? What's something you still find difficult?
Okay, so it's it was very difficult if I find that I just work very hard to try to make my score better and finally find that the top one of public leaderboard has a very big gap from our scores. And I have no idea why they can get such high score in public no public leaderboard. But finally finally I like 80% of the case I find that they are overfitting to the public leaderboards. So I don't know. I should say that is lucky or not because I was really looking forward to learn how they can get to such high score, but it finally turns out that they are overfitting. It's kind of sad.
I want to point out that Chishen has in his team with Grandmaster Bo and Gary, and also they're called Sheep on Kaggle. I don't know their real name. He has won 3 competitions as well, so he knows how not to overfit, and we'll be talking about that also very soon. Um, what competitions do you enjoy today, and what led you to participating in the TensorFlow one? Why did you decide to spend time on it?
Yeah, maybe you know that for past few years there are many image classification tasks or image segmentation tasks, and these competition are all very like well the solution of those competition are all well developed. So in the past year, there are not too many image classification or image segmentation competition. Instead, there are many object detection competition. So I think it's because cargo or the organizer of competition just thinking about that the object detection is still like they want more people to focus on object detection. They think this area is still under discovery. So I just um, of course, for specifically for the TensorFlow competition, it's because it's not only object detection, but it's also a video one. We don't detect object on single image, but on a video. So actually, I was like to try some object checking things because I'm not very familiar with that. I want to learn some technique about checking. So that's why I joined this competition.
Was this your first object detection competition?
Sorry?
Was this your first object detection competition that you participated in?
Um, sorry, I don't understand what you
Sorry,
mean.
Sorry, was this the first competition where you actually tried object detection, or did you participate in similar competitions before this?
Maybe 3 or 4 months ago, there is another object detection competition. It is SIM1
Mhm.
fiber. What I don't know how to pronounce it. So yes, actually, I'm not quite familiar with object detection and object tracking. That's the main purpose I joined this competition. Yeah.
Okay, thanks. Thanks for clarifying that. So, for the next part, I would like to explain the problem statement to the audience. So, I'll go through the competition page and just explain what I understand. If I say anything incorrectly, please interrupt me and correct me because I didn't participate. I was just there to read the solutions.
Okay, no problem.
So, from what I understand, here's a video that everyone can watch. TensorFlow channel made this video and they tell about there's this species of starfish that they want to protect, and the task is to be able to identify them through the video. So, what makes this challenging is it's not just an object detection problem, it's inside of videos. So, for anyone who's ever worked with images, knows they eat up a lot of GPU memory. Qishen has two wonderful A6000s. I'm sure they would have helped him a lot. He's also wearing
Yes,
the Z by HP cap that would have helped him. Um,
yes.
for for anyone who's worked with video knows it's even more challenging. So that was the main thing that made this very tough competition. Um, for the data, as I mentioned, you had videos. So inside of the train images, it's actually three videos that are there, and then you have to predict based on that, and you will be scored on the F2 score of your answers. So I won't explain what F2 score is. I would assume everyone knows this. And I also want to share a joke. I think that Chishan had made, he had posted this before the competition ended. And I want to point out that, as you can see, his team moved up 120 ranks. So this was one day before the competition ended. And I think you were making a joke that you want to learn from everyone and you knew you were going to win.
No,
for,
I don't mean that.
I think you knew you were going to win and you were just making fun
No,
of
no, no,
everybody because next day you'll just tell, "Oh, see, I won."
no, absolutely not.
Were you surprised by by the joke that I think it was a joke afterwards, but were you surprised yourself?
Yes, yes, sure. Our team, all 3 people in our team, all surprised that it finally turns out that our private score is the best. It's kind of how to say, like, actually we work very hard on this competition, and she find that higher resolution has better public score on public leaderboards. But actually, after like uh, 4,000 times 4,000 resolution, that there are not that different uh, on public scores. So actually, um, until the end of the competition, we have no idea how to get public LB score to 0.8 or something. That was unimaginable for us at that time. Okay, so it turns out that they have some trick to overfit to the public leaderboard by shrinking the predicted box. That was actually not that good, I think. Well, I'm not blaming anyone, but maybe some people is just like to digging little secret from public leaderboard. That's all. That's also okay.
So I wanted to mention this because this competition and Chishan's solution also says trust your cross validation, trust your CV. So this competition had a really big shakeup, as you can see. So there was a lot of difference between the public and private leaderboard. May I ask you, when you first approached the competition, how did you start applying your ideas? What were the first ideas that you started, and did you team up from the first few days or later on?
Oh no, I actually not teaming up with anyone when I joined this competition. I work by myself for maybe 2 or 3 weeks, and at that time I was like, for the first step is to read public notebook and public discussion to find out what most of those peoples are doing. Like I find that many people are using YOLO X and YOLO V5, and so I decided to start it from YOLO V5 as well, and like try to turning some parameter first, like turning the learning rate, turning the augmentation, the number of epoch, and find out the how the result would change. Yes, I was started like that, and after 2 or 3 weeks, I find that sheep publish very high score notebook. Maybe you know that, and
Yes.
yes,
He,
the other
may I
two
share
guys.
this story?
Okay, no problem.
So I believe I read all of the solutions this time to prepare for this interview. Steam published a notebook where he shared a trick, and then he got pushed out of the leaderboard. I think that was the story, right? Because everyone just used their trick and they went above him on the leaderboard.
Yes, yes. Like before we team up, Sheep is about to quit this competition, so he decided to publish his notebook. So after that, we decided to team up, and the other two guys, me and MVN, just blame him for publishing the very high public score notebook, and just like something like a leaderboard destroyer or something like that.
Uh, I want to just quickly mention your teammates. They are also both Kaggle Grandmasters in competition. And when we say sheep, I don't know their real name. Their Kaggle name is sheep, and same for their other teammates. So we are talking about Kaggle Grandmaster sheep because we don't know their real name. So
Yeah,
after
yeah.
that, sorry, please.
Oh, please.
I was going to ask, after you teamed up, how did you start applying ideas? And I want to learn, how does a grandmaster, while approaching competition, think of ideas? How do you apply them, and how does that happen behind the scenes?
Okay, so um, after we at the beginning of the team up, we have our own ideas, our own training pipelines, our own methods for pre-processing images. So after we team up, the first thing is to summarize our own ideas and tricks to share with each other, and we will like try other guys' ideas to see whether it would improve our own score as well. And then we will come up with a single pipeline that combining all tricks or ideas from all members of our team. And then we will begin to improve the pipeline. And like I when I have a new idea, I will share on our Slack. We communicate via Slack and share it to Slack, and maybe the other guys say just go ahead and I will try it. Or sometimes they will say no, I think the idea is just like a shit, don't try it. and, course they will explain why they think it, but like they have tried it on before on some competition before, and it doesn't work. So just please don't try it because it's a shit. So yes, if I didn't team up with them, I may have to try many ideas that are just not working. So yes, teaming up with many experienced guys is kind of like saving your time, not only on that you can like other guys to working, but they have some experience might help you to like avoid some time wasting. That's
Got it.
quite important. Yes.
A grandmaster also has the experience of hundreds
Yeah,
of competition, thousands of models. So you get to learn from them when you team up with them.
yeah. We always learn from each other. That is why I'm very happy to team up with other guys. That was very important for me, and it's more important than earning prize from cargo.
That's great to know. So now I want to summarize your solution. So I'll request your help to help the audience understand how did you design this solution and its overview.
Okay.
So I believe you've already shared that you found this trick of resolutions, and that's what is going on here. So you had trained six YOLO V5 models, and you had trained them on different resolutions, and you had also cut patches of images. So you had cut into smaller parts of images, I believe,
Yeah.
and from there the smaller portion. So like for example, right now I'm zooming in, and let's say this is the image. You would just train on this bit instead of the complete image,
Yeah.
and on there you had applied a bunch of augmentation. I didn't see a few names. So I didn't see Mosaic and Clahe, which I think everyone had used. Did you not find them useful for your experiments?
Yes. Yes. Actually, most of the default augmentation methods in YOLO V5 uh, uh, were very useful. But we find that rotation and transpose, specifically transpose, um, that are not in the default list of augmentation are also useful. So we just add it to the pipeline. And actually, we have to do many experiments on turning augmentation methods for the competition. Not only this one, but other computer vision competitions. We always have to do like 100 experiments on augmentation to see which augmentation methods is useful, which is not useful. It's not just by it's not just about the about improving CV scores, but also we can figure out some little secrets from the dataset by turning the augmentation methods. Just let me give you a simple example. Like if I add a new augmentation method to the pipeline called motion blur. Do you know motion blur? It's just
Yeah.
like when you take a photo and you have your hand is not very stable, and you got some motion blur.
anyone who anyone who plays games knows of motion blur, and I
Yeah,
would hope.
yes, when you playing a card game or like that,
Yeah.
you get your screen like many blur, and it's called motion blur. So if I add motion blur and find the local score improved, that means in the data set there are many images that are blurred like motion blur. Yeah. So this is a very like we experience or experiment do many experiment on augmentation to find the property of the data set, to take little secret of the data set and try to deal with them to achieve better scores.
So it sounds like image augmentation is really an important part of computer vision experiments. How do
Quite
you
important. Yes.
how do you decide what experiments to run? Do you just run a grid search? Do you just run all possible parameters, or how are you experimenting with augmentation when you say you ran 100?
Yes, the first thing is you should know what what augmentation methods are usually useful. Like you can go through previous competitions to find out what augmentation methods are they using, and finally you come up with augmentation method list. Once you have the list, you can like try it one by one and to figure out which one is useful and which one is not useful on current data sets. You must know that for different data sets, the optimized augmentation methods are different. Like what I just said, maybe motion blur might work on some data sets, but not on others. It's not always working. Yes, so you have to, when you switch to other data sets, you have to do it to turn augmentation method from the beginning, from the very beginning. So like when I have a new data set, I usually when I build a baseline on that, I usually use not use any augmentation method to have a pure score of the data sets, and then try to add augmentation methods one by one, but not many augmentation at the same time. If you do that, you won't know which one are useful, which one is useful, which one is not, because they are just like mixed together, and you just learned nothing from the experiments. You have to try it one by one.
I want to ask another question similar to this. You said when you started competing, you saw
Yeah.
many people say something won't work, and then you tried and it worked. Many
Yes.
times people just give up without trying till it works. How do you decide when to stop? Because sometimes you can keep trying and it wouldn't work because it doesn't work on the data set.
Okay, so how to say it? Because most of the time I will just have a gut feel, like I think it might work, but if some people is just post a discussion to say that it's just not working, but I will just first I will trust my gut feel and try it by myself. But like how to say, if you have attempted many computer vision competition, maybe you have that gut feel as well. You will know that at that time maybe this idea will work, at or at the other time that idea might work. Yes, if you have touched many computer vision data sets, you will have that feel as well, I think.
For the audience, I want to remind them that this gut feeling comes through 16 gold medals and 18 silver and 2 bronze medals. Gold medal is the most difficult thing to get on Kaggle, and when Qishen says he has a gut feeling, it comes through running thousands, hundreds of thousands of experiments in these competitions, I would believe.
Yes, definitely.
So now coming back to your solution, I'll keep going in sequential order, and please interrupt me if I miss anything. So now you have tried all of the augmentations, and then you had optimized them based on your cross validation. So your cross validation again was threefold cross validation split by video ID. So you were splitting across 3 sets just based on the video IDs that.
Yes, the training data has only three videos,
Hmm.
0, 1, and 2. So the best way to split the it's kind of like time series, although it's video. So we can just consider it as somehow time series data. So random splitting is just not good, of course. And of course, there are some people are splitting the data set using sequence ID. Sequence ID means that for a single video, there are many sequences in that video, and they are splitting the data via by sequence ID, and they have a higher series score rather than us. But actually, I think that might how to say, if we are optimizing our cross validation score, we have to consider the hardest case, like when the test stat is taken in a very different environment, then it will be very difficult to predict the starfish from that video. So we decided to split the data by video ID, just by imagining that maybe you have 2 videos for training and 1 for validating, and of course they have some diversities. They are not the same, and this is the most difficult case that we can split the data rather
That,
than instead of sequence split, we use video splits.
that makes sense. I learned I now I understand the intuition. It was split like time series. I was trying to understand how does this make sense intuitively. Now I understand the gut feeling of it. So thanks for
Yes,
clarifying.
yeah. So we have to imagine what the most difficult case, and we have to try to optimize that case.
Okay. So continuing in your solution explanation, after you got these bounding boxes, so for the audience in this, you would have bounding boxes. Like for example, right now Chishin's bounding box would say legend, Maya would say noob. So that's how you would have bounding boxes for all these starfishes. And after that, I believe you rescored or re-evaluated these predictions. So all of these predictions that you had gotten from these YOLO models were then re-evaluated.
Yes. We have like three. First, we train threefold models, and we find that for inference, it takes so much time for YOLO model for inference. So we finally, before we submitted, we train another model using exactly the same setting, but using all data. And finally, we only use one model for inference. And but when we are training classification models, we have to use OOF that is generated by threefold models, because it can avoid from data leak. So after we have our YOLO model trained and our OOF file generated, we ensemble those OOF files, and finally result in a very precise prediction with predicted boxes. And we crop them out, and then of course we don't resize it. We don't change its length and width. We just crop like a square. We don't, like, if the if the starfish is like that, we don't just simply resize it to a square. We just crop more environment information into that. And then we train classification model on it. Actually, after the end of the competition, we found that tried the similar methods like us, but many people uh, find it's just not working.
Okay.
Um, Actually, I don't know why they find classification model not working because from the very beginning of our classification model, it worked from the beginning. You know that because classification model also we have to build a baseline model for classification, and we find that our baseline is also working. And after that, we optimize the classification model and make it works better and better. And yes, actually, it can improve our cross validation, improve our CV like 0.0 near 0.03. It is quite a bit.
I think that's where the difference of your experience and other people's experience comes in. So, as you were talking about the gut feeling, that's where your experience was helpful in trying
Yes,
these
yes.
models.
Sometimes people may not hidden something. They may just actually find that it's not working, but not by accident or something. They for some reason they find that it's not working. I don't know why, but
Okay. Uh, so, I have two questions for you. May I ask why was very high dropout helpful?
yes,
Because I didn't understand this. And second is why did you use PC loss here?
yes. Because the F2 score for this competition, we have to compute 0.3, the threshold from 0.3 to 0.8, while the 0.8 is a very high IOU. If someone is very familiar with object detection, that you will know that many matrix we only compute IOU at the threshold of 0.5. It's a normal threshold, and because when we draw a bounding box on object, we might somehow it never be a very accurate the box, like 1 pixel left or 1 pixel up or down is not that different. So for avoiding that difference from the ground truth and the predictive box, so we consider if the IOU, the intersection of union between the GT box and the predicted box is bigger than 0.5, that would be a good box. But at this competition, we need to compute the score of the IOU bigger than 0.8.
Hmm.
This is very difficult. So actually, we have no idea how to optimize those predicted box at that high IOU because the quality of the GT box is not that stable. But
Okay.
yeah, it's quite normal because you know that different people are drawing, like using different computer to draw the bounding box, and they have their own habit to do it. So so the quality drawn by different people from uh, there are I should say diversity. There are quite a diversity for those GT boxes. So it's really hard to optimize the score at the threshold bigger than 0.8. So For why we use BCE, it's just like when we use regression, like if we use regression method to predict the IOU, it will be introduce many noise. Just like I just said, the quality of the GT box is not stable. So if you use regression, that will just like introduce many noise from the GT box. Actually the GT box is not necessarily better than predicted box. So in this case, we choose like binning the IOU split by 0.1 to make it 7 bins and use BCE loss to optimize it. Yes, like we consider the first bin as IOU bigger than 0.3, the second bin as IOU bigger than 0.4, and if the IOU is bigger than 0.9, we have all 7 bins equals to 1. Yes.
Just to explain to the audience, usually there with object detection, it's a bit relaxed for the IOU requirements, but here you wanted to perfectly identify starfishes. So you had, I think, the requirement of having a very close box on wherever starfish were in the video. That's why the score had to be very high, if I understand correctly.
Yes.
Okay. I was just trying to make sure I understand correctly. So
Yes.
um, thanks for explaining that. Now, just to cover the post processing, I want to ask. I saw many people using WBF. I don't think your team used it. So,
We also use WBF as ensemble.
oh,
It's not.
sorry.
Yeah, actually, we actually don't consider WBF as post processing method. Just like we are doing on image classification or image segmentation, we can use a very simple method to ensemble, like just take the average value of the prediction as ensemble value, ensemble score. But for object detection, it's not the case because you know that the different model is just predicting the box at different place and predicting the box at different confidence. And so we have a very common tool called WBF to ensemble those object detection model. It is introduced by very famous Kaggle. Maybe you know him. But actually, he's called ZF Tuber. I
Z
don't know.
ZF Turbo. I don't know
Okay,
their real name, but I
okay.
know they are a legend, and
Yes.
they,
He is very famous, and the WBF method is introduced by him, and it's kind of like every object detection competition. We all use WBF to do the ensemble after he published the tool.
just
So
just
yes.
wanted to mention ZF Turbo real quick. Once I went to their GitHub page and I saw that they have CNNs implemented in C++. I got very scared that day, and I knew that he is one of the best people just by that.
Yeah, so we haven't write that we use WBF because we just think that it's kind of like default. If you attempt a object detection competition, you have to use WBF by default.
Okay.
Yeah,
Sorry,
we didn't
sorry, I
mention.
didn't know of that. I was just asking the stupid question because I was curious. I didn't see
Of
it in
course,
your
no
write up.
problem. Yes. So yeah, so if you guys are just going to attempt another object detection competition, so please remember WBF. You have to use it.
Okay. Awesome. Thanks for answering that. I believe we have covered all of your solution. Any other things you want to mention?
Oh yes. I think there's another little stories behind our team because um, the F2 score described in the web page of the competition is not very detailed. So all of us just implement F2 score algorithms by ourselves, by our own understanding, and we find that we have many difference on the implementation. So yes, so at that time, MVNN just shared an OF file, and he claimed that the OF file has the cross-validation score at 0.62, and I download his OF file and compute by my own F2 implementation and find that from my side, the OF file should score 0.68. Like there is quite different from the implementation of F2 score. That is due to the cargo or the organizer just not explained their F2 score very clearly. Yes, yes. If you they have a equation on the page of the F2 score, but actually it's just not useful at all.
Okay.
Yeah. So okay, they even don't have an equation on the page.
Okay.
So
Got it.
like they explain that the predicted box should be sorted by the score, and the higher score, once the higher score is matched to a GT score, then the GT score should not be matched to other predicted box. But it's really like we have our own understanding and have different implementation of that of the F2 score. Yes.
Okay.
So finally, we find that the lowest score comes from MVNN. And I said before, we have to consider the most difficult case for the data splitting or the like, or we have to consider the generalization. So we choose to use the lowest one to as our cross validation score, which is come from MVM. So finally, our series score is at 0.74 for our final submission. Yes, I think if you go through the discussion or the notebook, there might be some people claiming that their series score is at 0.8 or something like that. But actually, different people have an implementation of F2 score, so it's just not comparable.
Uh, thanks for explaining your solution, and congratulations again on the first position finish. I think this was your third time you won the competition. I'm sure it was awesome, and thank you so much again for sharing your solution. Now I have these same questions that I ask every time. I would love to finish the interview by asking them. Someone has already asked this, so I'll use their question, which says, how do you apply what you learn on Kaggle to real life, real world? Do you find it useful, and have you ever found it useful?
Okay, that's absolutely very useful. Well, as for my work, for my full-time work, I mainly work on recommendation system, but sometimes some uh, computer vision task as well. Like I just mentioned, many tricks that are not only working on public data sets, but also work on other data sets. We come to Kaggle to figure out which idea, which tricks, which paper are not only working on ImageNet and Coco, but also working on Kaggle datasets. If it's the case, like we have a trick, we have a new CN architecture that are not only works on ImageNet and Coco, but also work on Cargo datasets. It must be works on our own datasets to of our own of my company as well. It's kind of like we have do many experiment on cargo, and we don't need to do it again using our own data sets actually. So like I have a very good setting at a cargo data set, and somehow sometimes we can just copy the pipeline to our own task, and it usually just gives a very reasonable results, although maybe not the best, but it's kind of good enough. Like because at company we are not doing competition. We need to consider both performance, both accuracy and
Yeah.
runtime, the speed of the model. So sometimes we don't need the accuracy to be the best, but we can for example, we use EfficientNet B7 when we are cargoing, and we just simply switch it to EfficientNet like B2 or B3 on our own work. Yes. So definitely many useful trick, many useful architecture, many useful ideas on cargo that can be transferred to our own work directly.
Okay. Thanks for sharing that. I Are you taking part in this competition? Are you looking at this because you mentioned you work on recommender systems?
Yeah. Yes, actually, we might. I and some of my friends at the company might take part in that competition in next month.
Okay. So
Yeah.
this is one of the most difficult questions some Kaglers have found. Are you
Okay.
ready? Because I want to share that Arios, I'm not sure if you know him, and Jiba,
Yes, of
both
course.
they found this very difficult. So the question is, which is your single favorite game of all time? One game that you like the most.
Sorry, I don't understand you.
Sorry, one computer game,
Yeah.
one video game that you like the most. So your favorite game of all time.
Okay. Okay. So it's like it's definitely not advertisement, but it's called Genshin Impact. Maybe you know that.
I know about it. Yes.
Okay. Yes, I like Genshin Impact very much, and I play it every day.
Okay. Thanks for that. My last question, which I always ask, is what is your best advice to someone who is just starting on Kaggle? So to a noob, what is your best advice?
Okay, so do read many notebook and discussion, but don't trust it directly. Just like you can trust it 50 to 70%, but do not 100% trust it. That's my advice. Yes.
Okay. Thanks for sharing that. To wrap up, I'll mention your Kaggle profile again to the audience so they can find you on Kaggle. On there, they can also find your LinkedIn profile and they can connect with you on LinkedIn. Any place else where people can find you?
Yes.
Sorry, are these the two platforms where you're active or any other platforms you want to mention?
Okay, not for now. Yes. You
Okay.
can find me at Cargo or at LinkedIn.
Okay, thanks for that. Again, thank you so much for your time, and it's been an honor learning from you. I also want to share with the audience. Jishin told me before we started that he doesn't interact a lot in English, and he was kind enough to do this interview in English. So we are very lucky because I know many Kaglers in Japan and China, they don't interact in English a lot. So we are really lucky to learn from him today.
Yeah, yeah.
Thanks.
Sorry for my poor English skills, but next I will practice more.
I didn't mean it like that. I just wanted to
No,
really
no,
thank you
no
for.
problem. Yeah.
So, any final words you want to mention before we wrap up, or should we should we wrap up here?
Yeah, just good luck cargoing. Yeah.
Okay. Thanks again, and thank you everyone who joined us today.
Yeah, thank you as well.